Um, oh yeah, so um, one thing I noticed from just a few individuals, but if you're waiting for your stuff for your pull request to be reviewed, that doesn't mean that you stop working. That doesn't mean that you can stop being productive. You can continue to work and continue building up your project as you have something else that's in a pull request that's up for review. The things might change, but you should be able to adapt to anything that changes up. Like, oh, I ask you to like add another method, or I tell you that, oh, this particular interface shouldn't be this way. You should be able to just go through your branches and be able to fix up those things between the two. Another part of the internship and what you will be learning here is not just the fact that you're using Git and all this stuff like that, but being able to continuously work on your software regardless of what's happening. An analogy that I think I forget who I told this. I think it was Delwyn. But analogy that I have for like developing software in this type of scheme is kind of like if you guys watched watch anime or like read manga, or you've watched a comic book, or like you're thinking about like a certain movie where like there's a written part and then there's also a TV part. They try to write books to keep ahead of the TV so that they don't catch up with each other. Because once they catch up with each other, the TV has to stop. The TV show has to stop and wait for the plot to continue. One thing that I do at work is that like I usually have like 3 different items I need up for review, but I keep only one item out there so people can keep reviewing that thing. If I have all my items out there, not everyone can review everything at once, and it may not make a lot of sense if you have to keep changing through different reviews. But you have one out there, and you continue to keep writing, and then once that gets merged in, you put out the next one. So it's kind of like putting the next book after, or putting out the next show after a sufficient amount of chapters have been done. So if you need to, what you can do is if you have one commit, if you have something that's in a pull request, go into that branch where that pull request is, where that commit, where the pull request is happening, then branch out from that branch, and then that'll be a linkage to the previous branch, and then you can work on all your stuff from there as well and continue the work. So is there any questions on that? Okay. Another thing to bring up is use enumeration classes. I'll show you a little example. I'm pretty sure this one has a good example of that, of really good usage of enumeration classes. So here we have an enumeration class for the bus mode, for the display mode, for the font, stuff like that. Really well put together. It's very easy to explain. Like if you were to write it out, it would be ST70 blah 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 display mode single line. So you can read through it and go like, okay, so the driver for this thing, it's on display mode, it's single line mode. That's what happens there. The usefulness of using a enumeration class versus enumeration is that enumeration classes are actual types, whereas enumerations are kind of like macros that have, they're kind of like constant expression where, actually they're literally constant expressions. They're compile time expressions that don't mean anything after it's compiled. These are actual real types. Now, what that means is, if I try to pass, let's see if there's an example here. There should be at least one. Here we are. Write operation is an enumeration class. Yeah, it's an enumeration class. So if you attempt to just put 1, 0, or whatever number you feel like to put into operation, the problem there is that like it'll throw you an error because it's like, hey, you put in an integer and that's not the right type. The type is a write operation type. So it forces you to actually use the enumerations inside of the class in order to operate these things. So it ends up just keeping people from making silly mistakes. You limit the span of options the user has to put into this object so that they're only really putting in proper operations for this object. Kind of going back to the assert thing. Let's say if you had a class that took in a float and there was a definitive range between things that they could have, the caveat to having that huge range and having a range for a variable that can go anywhere is that now I have to put in an assert to make sure the user doesn't go beyond that. But if you use enumeration classes, if it makes sense for that, you restrict them to only be able to use what's inside this enumeration class. And if you need to if you need to, let's say, use it in other places, you can cast it back into its previous type, or you cast it into an integer type. You also pass it around and put it through places that would use their underlining type word, be like a U and 8. So it's still really nice to pass around. It can still be passed around and worked with. This is not useful though. Let's say you want the user to be able to put like a 1 or a 0. Let's say the write it's 1 if it's write operation, a 0 if it's a read operation. If you want the user to be able to do that, then this is a better approach than to just not have an enumeration class, have it just enumeration. But in most cases, it should be an enumeration class. Any particular questions about enumeration classes?
Can you hear me?
Yeah.
Okay. So just like, for mine it's pretty simple. Like I'd have like 1. See, I understand if you have an enumeration, you have like 2 or more. But if you only have 1 object, 0 point something, or 1 like single like variable, there's no reason to use an enumeration, is there? Or should I just name it that?
No. So you can kind of see this, like right here, the static cost expression KSPI function. The idea here is that like if you only have 1, it should just be like a cost expression static variable inside your class. And the thing is like usually if it's a the enumeration class is really useful when you have the users pass in parameters, because it forces them to put in that specific parameter. But if the parameter can only be one thing, then it doesn't really matter. Then like you would not put that in as a parameter. It would just simply be you'd omit that. Does that answer your question?
Yeah.
Okay. Cool. All right. Next item. Yeah, using the right radix for the right job. So this is good. I love this. It's in decimal, but it's very easy to understand. Like, oh, this is like pushing over it by 4. It ends up being a 0 at the entire time, but it kind of gives the idea of like, oh, this gets pushed over by 4. This gets pushed over by 3. This is the third bit. This is the second bit, so on and so forth. I think there was one case. I've seen this, and it's not just this commit. I've seen other commits that got merged in before they got merged in. I saw people doing conversions of their of certain things, and I could be actually completely wrong about this, but it's just something that popped up, and I thought I would make a point of this. Let's see, where is it? Here. Yeah, David, correct me if I'm wrong, but I see you put 18 here, and you also put hex 12. If the value, which is true, if the value that you want to kind of illustrate here is supposed to, looks easiest, it makes most sense in hex. Like, for example, somewhere in the data sheet says, like, you want to put in hex 12, blah, 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 into this register. It's better to keep it in the radix of hexadecimal versus keeping the radix as decimal. Because now I have to, if I look at that and I look at the data sheet, I'm like, okay, I think it says 12. Wait, hold on, is 18 12? It is 12. But the fact that I had to make that mental step, I should be able to just kind of look at them and see if they're identical. So if there's any point in time where you are, if some documentation that you have or something that you're using typically uses octal or hexadecimal or decimal, use those radixes. It'll make the code more readable that way. Any questions? Okay. Yeah, the last one, which is the one I just added, is the dependency injection branch. So whenever you're developing, whenever you guys have questions about like how to do certain things, at least like in the main class, go to dependency injection, go into firmware, and then go to L1 drivers, and you should be able to go to SPI, and you should be able to look at what happens here. So this is a good example of how to do dependency injection, and then what do you do with these pins? You still have to initialize them to something, so how you initialize those. And then I think the test also goes over a very basic way to be able to make mockups. So, I'm trying to think. Oh yeah. So David, in this case, You can use this as an example to see like how you can kind of mock things up. Right here, all I'm doing is I'm just giving all of the pins for these particular methods that I'm actually going to be using in this area here, where you used in your example GPIO set high and low. I think you could just fake those two methods and just keep it there. And then you could not only just fake them and give them empty stubs, but you actually give them actual functions to run. So you can, it's almost exactly the way you have it before. Just rather than you creating your own class, you would just use mocking. You'd use this interface. It's also safer to use the interface because the interface should never end up touching any hardware, whereas the class's initialization may end up doing something along that line, somewhere along that. Also, there's a weird typo in here because I think I was trying to save stuff into this file. You could ignore that for the most part. But yeah, that's pretty much what the point of using the mocking system and why we have interfaces in the first place, so that you could very easily mock them up using fake it. Any questions on that?
So this, the test that you've got going on, it shows a great way on how to mock for like the pin configure and stuff and things like that.
Mhm.
Can we be doing the same thing for our own classes when we're doing that?
Yes. Any dependency that you have, you should try to test the interaction between them. Now, sometimes you don't have to. Like, for example, I'll show you what David currently has, and he only needs to test for a small portion of what I'm talking about. Where is it? Go up to the top here. Whoa, 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 whoa. The way that he goes about testing is he does test by side effect, and will also, if he includes fake it, also be doing test through interaction, basically, which is not, we had another word for that, but I'm trying to remember what it is, but I can't remember the exact name. But this is through dependency injection. So right now the dependency is on the pin configure, but we don't want it to, or on GPIO, but we don't want GPIO to actually run because we don't want it to do its normal thing. We also want to you actually don't even have to mock that up at all. All you need to do is spy on a GPIO object. Yeah, actually. So actually, if you needed to change the way that these functions were run, you could do that. And then what you can also do at the bottom section here is after you run your function, you can actually verify that the pin structure matches what you need it to match. Like this pin is equal to blah, this pin is equal to blah, blah, and so on and so forth. But I would say that this function, these methods already do this. So once you change this guy here, or you set this up to do this, this will just happen by default. So, yeah. I'm sorry, did that answer your question?
Sort of.
Okay. Can you restate your question again?
So basically, if we're looking at your
Is it the dependency injection?
yeah, it's in the dependency injection.
Um.
In like the test CPP, right? So you've got the mocks and the fakes for the pin configure stuff,
Mhm.
right? So that's good to go. Do we also need to do mock and fake for our own type defs in our stuff? Do we also need to do maybe I'm not sure what I'm asking for yet.
I think I know what you're talking about. So one, if you're testing your class, you would never fake it, unless your class took more of itself, like somewhat like a linked list or some other type of weird structure. But no, you would never, like, your interface is for everyone else to use to mock up and fake your class later on. So I made pin configure interface not only to be a contract for pin configure the class, but also to be a tool for you guys to use in order to mock up these guys otherwise. Because otherwise you guys couldn't create mocks of our classes and couldn't do what we're doing here without that interface. That's why it's a rule for every class to have that. Going further on, yeah, you would need to do your own class, but if you have any dependencies specifically that your class is going to end up using, if you're writing a test for a particular thing, let's say in this case, I don't know, testing pin function, just simply testing that out. If you need to make those calls and you need to get information about that, you need to stub it out or fake it out or somehow. You have to look at a way to get that information about how it was called. In this case, I fake these so that when I run this thing, I should know that each one of these is set to this particular, at least got ran with these parameters. As long as this module here was tested, I don't have to worry about testing even further. Kind of going back over to the ST example, this is actually good because it actually makes his tests shorter. But if it wasn't that useful, and let's say David decided to just actually end up testing GPIO, like in the process of trying to test out his own module, he's kind of stepping beyond the boundary of where the test should be. It should be its own separate test that should be completely validated on its own side, and then this thing just uses and assumes that that thing works perfectly, and then builds from there. So I kind of went beyond your question, but yeah, that's pretty much the situation.
Okay, so another question, same sort of thing. You have a test for test the pins, right?
Mm-hmm.
But you don't have a test for the actual SPI protocol or communication. Is that something we need to worry about for our stuff?
Sorry, say that last portion again.
So in your SPI test
Mm-hmm.
.cpp file, you have the part for test pins,
Mm-hmm.
or test pin configure,
Mm-hmm.
right?
Mm-hmm.
So yeah, test pin function. Now we also need to have a section, since this is SPI, we'll go with this, but test SPI output or protocol or something like that?
No. So because that's handled by the hardware and there is no way to inspect that, there's literally no way to inspect that in host side, in a test that we run here. We can only hope that when we write to certain registers in a particular way and that we do it the right way, that the hardware will react in the appropriate way as well. And even if we are on an actual device, there isn't really much of a way to do that without doing a loopback test where you connect a couple of pins to the SPI pins and then use interrupts in order to check to make sure that the protocol is being adhered to. But for the most part, from our point of view, that shouldn't be necessary whatsoever. Any other questions? Okay. Last item, which is actually my second item, was so I only have like GPIO in tested without a demo. I really want to push you, like you guys, like we don't have very much time left before we have 13 days left before the date actually be there and have everything ready. So if anything, it's actually like 12 days left. I want to see you guys put a little more effort, really kick it into gear this last week. Try to get those pull requests in. I'll be reviewing them as quickly as I possibly can. My review throughput has not reached maximum. I'm not overdone with stuff. Keep in mind, like I said before, if I see an X here, I'm very unlikely to check it out. If it's been there for a while, send me a message and just say, hey, what's up? And a while could be a good portion of the day. And just send me a ping so I can go, oh, okay, I need to go check this out. And a lot of times, there's stuff that is really quick to fix up. For example, if you go to ADC, the only reason why I haven't merged this in yet is because of the fact that the interface just remove this underscore and make this lowercase and then capitalize these, and then you're pretty much done, and then get this all lined up. And that'd be pretty much it. So if you're still at the interface stage, get that merged in as soon as possible. I'll be working on this on the weekend as well. And if you are in the implementation stage, try to really push to get everything finished up. yeah, if you're on the interface stage, there's no reason why you can't get that done within a couple hours. So, any questions on that? Okay. Are there any questions in general? I've actually gone over time, but are there any questions in general? Alrighty. Okay, cool. All right, so that's pretty much that. I'll be around this weekend. Oh,
I had a question.
okay, go for it.
It was in the chat.
Oh. Oh, okay, real quick. Yeah, so we need to have, so basically printf, as it stands right now, the normal printf will try to allocate memory. We don't want printf to allocate any memory. VSN printf, which is the variadic string number limited printf, will allow you to put in a variadic list, will allow you to write it to a buffer, to a string, and then it also limits itself to how far it'll write out. You can specify those kind of things. I need you to get that to work with a static list, but you should be able to put in an arbitrarily sized character array into the printf function. So if I put a string that's 1,000 characters long, the printf that you designed using VSN printf should work. It should still work with that. It needs to loop. It will have to loop through it, but that's pretty much what needs to happen with that. That's how you improve printf. So at that point, what we can do is we can have like a buffer that's, let's say, 128 bytes in length, and then all we do is iterate through that a couple times before we get through the entire thing and send it all through send it out. So that's what you're supposed to be working on. And yeah, Jeannie, see if you can get a PR for this, like something demonstratable by Tuesday. I want to see some progress on the printf, on the improved printf. Okay. Other than that, any other questions? Alrighty. If you guys have any other questions, you guys can ask me the questions on the Compy SJSU Slack. I'll be working on I2C. Nicole's not here. I'll be working on I2C, so that'll be another module that I'll be putting in. Yeah, if you guys have any questions, just ask them there. Oh, and one other thing I forgot to put in. If you are getting like the no main exists error, make sure you're inside of a project when you compile. If you're not in a project, there will never be a main, so it won't work. And that's pretty much that. All right, have a good night, guys.
See ya.
You want to see the errors that I'm coming up with?
Sure. Let me pause the recording real quick.